Okay, so special right triangles today. We're going to talk about one of two of them, the 45, 45, 90. So the 45, 45, 90 tells you the angles in the triangle, okay? It's obviously a right triangle, and it has these three angles. So do you remember from geometry, if a triangle has two angles that are the same, what kind of a triangle must it be? If it has two angles the same, it must have two sides the same. Exactly. So if all three angles were the same, all three sides would be the same. So this triangle has to be a right isosceles triangle because I have two angles the same. So gonna look something like this. There's my 90. So then if these are both the same, they would both be 45s, right? Does anybody remember how the sides relate to each other? So in other words, these two sides are going to be the same length, right? So let's just say they were each, I don't know, 3 units. You're 3 and you're 3. Does anybody remember what the hypotenuse is?
Whatever the number is on both sides, and then like root 2.
Yes! It's just whatever this number is times root 2. That's it. So this is just 3 root 2. Now, if you didn't know that, of course you could do Pythagorean theorem and find it out. So let me just prove it to you. So pretend I didn't know that for a second. What is 3 squared plus 3 squared is going to get me c squared. So that's 9 plus 9. So that's 18. Square root both sides. So c, let's see, doesn't that split into 9 times 2, right? And the square root of 9 is 3. So voila, 3 root 2, what do you know? So turns out that this works no matter what these numbers are. It could be 15. You would get 15, 15, 15 root 2. If it was 27, you'd get 27, 27, 27 root 2. Doesn't matter. It's always going to work that way if you have a 45, 45, 90 triangle. Right? It's so cool. So usually how we kind of set it up just to have a generic one, we just set the side lengths as x, and then this is whatever x is times root 2, right? As long as these are 45s. Is this ringing a bell? You remember this from geometry? Okay, cool. So let's try this. What if I told you in this, by the way, do you remember from geometry that these markings mean that those two angles are the same? If they're both marked with one arc, then they have to be equal to each other. So I don't actually have to write that they're 45s. I could just mark it like that. Because now you know these have to be the same, and all three have to add to be 180, so there's no option for it to be anything other than 45. All right, anywho, try this. If this were 8 root 2, what would this side be? 8, right? And so would that one, because these two are the same as each other. Going to make this a little bit more difficult. You ready? What if this side was, I don't know, how about 5 root 3? Well, what would this side be? 5 root 3, of course. And what would this side be? 5 root 6. It's whatever this side is times root 2. So if I just do 5 root 3 times root 2, remember how radicals work. Anything that's under the radical, you really can multiply together. So you just get 5 root 6 for that. Does that make sense? Okay, so make it a little bit more interesting then. What if you had all right, you ready for this one? What if this was 10? And you had to figure out these other two sides. They're going to be the same as each other. Okay, but what are they? Or how would I figure that out? Yes. It is 5 root 2. How'd you know that? So you were thinking, what would you multiply by root 2 to get you 10? Really, what that is an equation. What do I multiply by root 2 to get me 10? Can't you solve that equation now? Yeah, just divide both sides by root 2. You can't leave a square root in the denominator, right? So I know you get 10 root 2 over 2. But then can't you just cancel those two out and get 5 root 2? Now, she was able to kind of process that in your head, right? You were just thinking like, okay, what would I multiply 5 root 2 to get me to 10? Unfortunately, so that one, yeah, you could maybe do that one in your head, but sometimes they're not going to be quite so easy, right? Like, what if it was something like, oh, I don't know, 3 root 7? That might be a little tougher to do in your head. Hey, maybe you can. But I'm really just, what I really want to do is I want to divide this by root 2. And then that'll get me what this must be. Because I want to take this and I want to multiply it by root 2 to get there. So I can sort of do it in reverse. You can set up the equation the same exact way. What do you multiply by root 2 to get 3 root 7? And now just solve for x. So I have 3 root 7 over root 2, but I can't leave it like that, right? What do I have to do to clean this up? Yeah, multiply by root 2 over root 2. So what's my new numerator? Yes, and what is my new denominator? 2. And that's my answer. That doesn't simplify any further. No one's going to cancel those two, are they? I hope not. You can't reduce the 2 and a root 14. If one number's in a root and one's not, you cannot touch them with each other. They cannot simplify. You could do these two if they had something in common, right? If it was 4 over 2, you could reduce them. 3 over 2 doesn't reduce. They either both have to be out of the root or they both have to be in the root. You can't have one in, one out. I always like to think about it. I don't know why my mind goes to this, but I just remember my little brother was actually like way stronger than I was always. I don't know why. We used to call him Bam Bam because he was just super strong. Just came out that way. I don't know. He was a terror. He used to bite me and hit me, and he was awful. So I used to always have to like run away from him. Well, if we were both in the house, he could get at me. If we were both outside, he could get at me. But he couldn't if one of us was in and one of us was out. You see? So you are protected. One's in, one's out. Oh my gosh. He doesn't bite me anymore, but he's still annoying. Anyway. So yeah. So this is an example of one, I don't know. I probably wouldn't use the brain energy to try and figure it out in your head, even if you could. It's probably just easier to just do it on paper. Okay. Does this seem okay-ish? We're kind of remembering. And that's how all your 45, 45, 90s works. I mean, it can't really get too much worse than that. Yeah, the only thing I could think I could do, maybe you could start off with a fraction. So what if I told you this was something like 3/4? Even that's not that bad. So what's my hypotenuse have to be? 3/4 times root 2, right? Or 3 root 2 over 4. Not too bad. Okay, so let me try and explain this little mini project now, if that's all right. So, this here is really just kind of a note sheet to remind you. So there's the 45, 45, 90, x root 2. I do mention some Pythagorean triples down here. We've talked about those a little bit. Just nice to kind of see them in front of you. We will talk about the 30, 60, 90 triangle probably tomorrow. But in the meantime, 12:05 we're going to go, right? So let's see if I can finish. I'll stop this video.